And so I think that, I have a few prompts as we go through this meeting. I'll go ahead and say those, but I'm not, people should talk about whatever they feel is most important. You can ignore my prompt if you want. I really appreciated some of the conversations I've had over the last few months with Jonathan Gott, who's the director of the USGS Landslides program. So I was going to go ahead and put him on the spot first. And I'm particularly, the prompt I had there is, I'm particularly curious about how technical systems that we'd use to monitor landslides, how you see that interfacing with the sort of softer efforts of public education and that sort of thing. How do these things balance against each other? What is the, and then how does that fit into the bigger picture of real mitigation of a hazard?
So thanks, Hig. And I'll introduce myself. So in case folks don't know who I am, I'm Jonathan Gott. I'm the program coordinator for the U.S. Geological Survey's Landslide Hazards program. And amongst USGS science programs, the Landslide Hazards program is amongst the smallest. So roughly the annual appropriation or the funding we work with on a given year is about $4 million. That supports about 20 scientists and engineers who focus on understanding landslide hazards and delivering a few tools for landslide risk reduction. And some of that has to do with education and outreach and kind of what Higgs asked me to touch on today. We got involved with the Barry Arm situation through Peter Heusler, who's also on the call from the USGS. And just kind of broadly what our role is with the situation at Barry Arm is really helping this interagency group deal with the landslide process aspects. And we've stood up a surveillance project, if you will, over the summertime using radar analysis from satellite imagery primarily. And we've been working with the folks at the state, Gabriel, who's on as well, representing the state. Anyway, so Hig asked me on today to touch on sort of how do technical systems to monitor landslide and public education and outreach and coordination interact with each other. And this really is reflecting on sort of what can be done for slides like the one at Barry Arm and elsewhere in coastal Alaska in particular, or anywhere really, from a technological solution, if you will. Basically, can we observe landslide processes or behavior in such a way to inform decision making with regards to hazard and risk? And that's the big picture question. From the USGS perspective, that's not something that we do routinely. Most of our monitoring activities are done for research purposes, basically to better understand how landslides work, what triggers them, conditions, etc. However, in a few instances, we've taken that expertise or applied that expertise to establishing what I would call an alert system or a warning system for some specific activities for limited periods of time. And that really reflects kind of the limited capabilities of the program. Unlike the volcano hazards program or the earthquake hazards program, the landslide hazards program, the USGS does not operate a landslide monitoring network for situational awareness like those other parts of the organization do. However, we have, like I said, have done this on sort of a emergency basis in a few instances, and some of the lessons we've taken from that really have, and this speaks to warning systems generally, and I'm sure James Gridley can speak to this more authoritatively than I can, but it really comes back from comes down to not what are the technological ways we can observe landslide behavior, but really focusing on the other end of the spectrum is, well, what do you want people to do with that information? And so for any instance, so what are the protective actions that people at risk might be able to take? How much time do they need? How willing are they to take these actions? How tolerant are they of false alerts, et cetera? So really focused on the human behavior side of the people at risk or the organizations at risk. What action can they take? And if you start from there and work towards the technological monitoring aspects, then maybe you can build an approach that'll be effective. And then from the landslide cases, so how can alerts be delivered rapidly, reliably, and fast enough, and what information should they contain? So that comes at the alert message part of it. And clearly for all community, the alerts need to be tailored for the at-risk communities, and sort of the lingo that gets used is meeting people where they are. I'm providing the information where people are. And that leads to sort of what can the landslide behavior or set of behaviors would actually trigger alerts. We're talking about landslides. Is it landslide motion? Is it hydrologic conditions? Is it something else that would cause us to throw the switch for an alert? And then if you have the answer to that question, you can start to design a monitoring system that can identify that critical landslide behavior, again, whether that be motion, hydrology, et cetera. And then can that monitoring information be collected, transmitted, processed, and analyzed sufficiently and reliably fast enough to trigger that alert? And so that really comes to a systems design standpoint and redundancy and all those kinds of good things. And from our experience, the systems that the operational systems are, I don't know, order of magnitude more costly, but significantly more costly than research systems, of course. And it comes down to, what do you need to have those systems to work, and to have the people to evaluate that information if you need a human component in the decision-making process to operate 24/7, 365 days a year in perpetuity. And that in perpetuity is a critical component of it. Any of these systems are in place, the stakeholders and the public tend to rely on them. And as long as the hazard remains, if you've taken responsibility to start monitoring and issue information on the situation, then in essence, you're on the hook forever until the situation changes, the hazard is reduced. And from a governmental standpoint, we view that as a very long-term commitment. In essence, you don't start on these things without a clear exit strategy. And with that, I'll turn it over back to Hig.
Yeah, and thanks for introducing yourself, Jonathan. It's great if everyone can do that as they speak. And also, just for the sake of time, we'll have to keep things pretty succinct. But I was curious if Lars and Finn from Norway, if you could speak briefly about what your experience is, being essentially I think the only place in the world really that has a system operational that involves warnings for landslide-generated tsunamis.
I can start. Do you hear me? Yes. It's a bit of a long story, but is it possible to maybe share the screen so I can try that?
You should be able to now, yes.
Yeah. Do you see something?
Looks good.
Is it okay?
Yeah, that's coming through.
Okay. Actually, I don't remember what title you get. You passed on to me, but at least saying something on the our technical codes and how we do the hazard risk classification, actually, because that's controlling most of what we are doing. And the background is, of course, that we had some large historical events, like one of these in one of the fjords in the west coast. This is a picture before the large rock collapse, which triggered or generated a large tsunami. So it has potential to make a large catastrophes. And this is one of our monitored sites in one of the fjords. It's which can have a maximum volume of more than 50 million cubic meters. And here you see the upper part of it with a pronounced back fracture, about 500 to 600 meters long, moving between like 2 and 8 centimeters per year at the moment. And this is some of the fjord areas which is in danger, just to let you have a background. And it has been done some kind of a national risk event or a national risk analysis of some serious threats in the society. And actually, the one rock slide is coming up as one of with the highest risk, with a probability on this axis and the consequences on this axis. And this number 6 is the pandemic event, which we are in the middle of now. It should be somewhere up here probably. But the technical codes, which is important, we have like 3 or maybe 4 different classes in terms of probability and hazard in our technical codes. It's 1 to 100, 1 to 1000, 1 to 5000 annual probability per year. And then it's a 0 class, which is like socially critical of national or regional importance, large hospitals, emergency centers, and so on. But the 1 to 1000 is the normal like requirements for the safety for normal houses less than 10 people. 1 to 5000 is like larger houses with more people, schools, and so on. And 1 to 100 is less critical. So this is what our technical codes say. And we have requirements in the technical codes about 24/7 early warning. So we have exceptions for these technical codes if we have an operational warning in place. So if you have like a large areas with a rock slide with a probability larger than 1 to 1000, and it's a lot of consequences, we can have monitoring and plans for warning and evacuations. So our responsibility, I'm leading a section in the government which have the responsibility for monitoring of large rock slides. And this responsibility is including that we communicate alert and hazard level to the municipality, police, and county governor, and the municipality has the responsibility for the evacuation and warning people. So we follow the mountains and warn the municipality. So that's our responsibility. And then our codes. So we have this law that allow buildings in tsunami hazard zones. And there we have technical requirements about instrumentation, infrastructure, redundancy. And it's requirements of real-time monitoring 24/7, both on the technical part and like the geological part, the interpretation part. And it said that warning should be executed in minimum 72 hours before an event. That's actually in the requirements. So this is some kind of a condition which has to be in place if there's going to be new activity in the hazard zones. This law is in revision, and it may also open for buildings in the direct runout zones for rock slide if the monitoring requirements is fulfilled, not only for the secondary tsunami effect, because at the moment it's linked to tsunami. So this is the kind of data we need for do the monitoring. We use movement displacement data from different kind of sensors, both on the surface and in the subsurface. So this is actually like the main like concepts, I think. I have some, but of course the question is, let's see if we can go back here. how to come up with the probabilities. So I don't know if you want me to present something there or not, but it's probably not time today because
I think that I actually am super curious to see that, but I think that you know, for the sake of getting through kind of a variety of perspectives, that maybe we'll save that, and that can come up. It might come up in conversation afterwards, if that's all right.
Yeah, I think so. But I wonder how to go back from the sharing of the screen.
Yeah, it should be if you mouse down to the bottom. I think it should give you a stop sharing option somewhere down there, or maybe I might be able to do it from my end.
I don't see anything there.
Lars, can you go back to the slide after the slide number 9 there and just explain the labels that you have on the graph when you have the color-coded warning system? I understand them because I can read Norwegian. Maybe others.
Okay.
Yeah.
When was that? Was this one? No, the other one. I don't know. This one. This one, you mean?
Yeah.
Yeah.
Yes,
so this
you got
is
it.
This is more or less like the concept for the warning. Where we have the green, which is normal situation, yellow, like the first level of increased warning, and orange, and then red is the normal evacuation phase, but also the orange. We do evacuate critical institutions which you need long time for evacuation, for example. But there is plans for this. We have a national plan, and we also have plans for each site how to deal with this. And the municipality has their own like early warning plan. So this is the curve is visually showing displacements.
And that's a rate in millimeters per day?
Yes. Actually, we have, of course, some threshold values, of course, in the beginning of an event, which is saying something about when you're moving from one hazard zone to another one. But of course, in a critical situation, we also had to evaluate not only the threshold values, but the totality of the different sensors in different sectors. So there is some kind of an interpretation. And we also will adjust that during an event because we get new knowledge during an event. And this is the critical part, when to increase the hazard level. So this is like because there is a lot of uncertainties connected to this. It's not numbers. So we have a group, 5-6 geologists who have the responsibility for the warning. So when we are going to increase the hazard level, we have like a separate meeting going through every data, discuss what are our opinion. Do we want to go up or no or not? So this is how it operates in real life. Because we can't just rely on a number.
Thank you, Lars.
Can you try to
see if I can take away your control?
Stop.
Let's see here. I can stop your video. I can kick you out. I don't see a way.
It's not easy. I don't know how to.
Is it not at the very top of the screen? If you move your mouse to the top
of the screen. Yeah, but they just get into like green.
I can do it. There we go. I found the option on my end. So I was going to call on Kelly and then on James. And Kelly, I was wondering if you could just give a little bit of picture of what kind of your experience has been, living in Whittier and with, this discovery of the hazard at Barry Arm and what that experience has been like for you, and especially like thinking about where you would hope this goes in the long term.
Yeah, thank you. I am a little overwhelmed with the expertise here. So I'm just a citizen in Whittier, but we operate a charter boat business and it's a pretty small town. The main problem for us is we really heard about this very secondhand. You know, some of us I heard about it when the Daily News called me and asked me about what did we think about the tsunami. And so, you know, most of our businesses are right there on the harbor. And in the summer, we have sightseeing boats, we have cruise ships, we have big groups of campers and kayakers that are on the beaches in different places in Prince William Sound. Our community is definitely right in the danger of the wave zone from the models that we've seen. So our business.
Oh, I just lost your audio, Kelly. Ooh. Yeah, I can't hear you. It's no, that didn't help. I can read your lips. Okay, all right. Well, so while Kelly's getting reconnected, I wondered, James, can you speak a little bit from your perspective in National Tsunami Warning Center?
Yeah. So what do you want to know?
Well, I'm curious where, I mean, the big question I see kind of putting all this together is where are we going? You know, what is it that might, what ideally would this, would our capacity to monitor and conduct warnings, and also things that are independent of that, you know, broader public education, routing measures for ships, whatever we might do to mitigate this hazard. You know, what is it that we're actually aiming for here as far as landslide-generated tsunami hazard?
So our mission is to protect life and property from tsunami, to warn on that, and to warn the emergency managers and the public. So this is a little different for us because we do it on more of a global scale normally. So this is kind of a new area for us to get very specific. In terms of where it's going, I think has yet to be determined for us because of funding and mission and government. But clearly there's a need. And since we are the National Tsunami Warning Center, they come to us. So I don't see this going away anytime soon. Right? I think we're growing into this is what I think we're doing. What would be really helpful for us from the research community is a better understanding of landslides and how all this works. And is there a way that we can easily monitor and have that sort of pre-knowledge, some pretext? And we don't need to know by the minute, but it sure would be nice to know, you know, week by week, so to speak, what's our status. And Jonathan's doing that with us to some extent. USGS, they talk to us often when they have new information. They tell us exactly what's going on, what they know, and that helps inform us. So I think, yeah, to sort of make that one continuum of information and understanding would be really helpful for us. And that would help us then know when to look, when to be watching, because, you know, the landslides, for us, we're not gonna warn on a landslide, we're gonna warn on the water measurement, because the landslide part's just too tricky. And, you know, our mission is in the water. So I mean, I think in the big picture, that's where our efforts are, or where I think it needs to go. I don't think we necessarily need better sensing equipment for the water side. I think it's fairly straightforward. We need more resources, obviously. But I think the other part of your question was sort of reaching through then to the public. And what does that look like? So I actually have a guy who does that. He's my expert right here, Dave Snyder. I'm gonna let him kind of jump in here. He's our National Tsunami Warning Coordinator. And his expertise is in communicating and dealing with the public. So I know we've done some of that. So I'll let Dave just kind of jump in there and tell us more what we've done and where he thinks it's going.
Yeah, thank you, Dr. Good morning or afternoon, evening, everybody. I guess, yeah, as soon as we learned about the threat there from this academic group there, Kelly's community was one of the first places that we reached out to as quickly as possible to make sure they understood what we were capable of and what we weren't capable of, which at this point is still unchanged. We are unable to monitor beyond any motion that the USGS and Alaska Department of Natural Resources is monitoring. Beyond that, we don't have a way to know that a wave has left Barry Arm and is moving toward Whittier or Valdez or any of the other Prince William Sound communities at this point. But what we are capable of doing is reminding people that Prince William Sound is a known landslide hazard area, and that landslide tsunamis are something that does happen in Alaska, and that we can be prepared by paying attention to the natural hazards and the warning signs that we're given by seeing strange and unusual things happening at our coastlines, and reminding folks of Whittier and Valdez and Cordova, Titlik and Chiniga that, you know, these are things that do happen, and when we see these things, give them their due respect and take action immediately. Other things that are typical for the National Weather Service in communities like Whittier is to work through a tsunami ready program. And that is a preparedness program that works with local officials, the public community, Chamber of Commerce and businesses if they so desire, as well as the state of Alaska and the National Weather Service, to make sure that we all have a plan and understand what the plan is supposed to look like and how that works, and practice it through education and a mitigation factor. And that is something that is it's a visible outward public sign, and actually road signs in communities that say tsunami ready, but something that we encourage communities like Whittier to pursue and renew. And that's where Whittier's community is right now, is in kind of that renewal stage. Dr. Gridley, did that cover all the areas you wanted me to hit?
Yeah, I think so. So our current status is that we are now waiting on the last of our paperwork to install 3 stations. It's looking less and less likely like we'll get that done before weather just freezes us out for the winter. So
I was curious. Yeah, I was curious how the earthquake aspect works into this for you guys, because you know, this is something that's really different for us here in Alaska than it is in Norway, where they, you know, this sort of curve that Lars showed of increasing motion, you know, that's if you're coming from the landslide perspective, that's sort of the ideal, right? That you get some progressive change until failure happens. In Alaska, that could happen, and probably did happen with some of the big slides we didn't monitor, but it also can happen that there's a big earthquake and a slide that, you know, hadn't shown any particular signs of failure would fail abruptly during that earthquake. And I think a lot of people in Alaska know that, you know, the earthquake is part of the warning. You know, if you feel a strong earthquake, you should consider evacuating immediately. But how does that fit into what you're doing specifically with Barry Arm?
So from our point of view, I mean, this thing can go, it can deform to go in, or it could be, you know, it could be a pretty good signal that leads up to it. Hopefully the USGS gives us some idea of what's happening before it happens and how that will go. I think, not really sure I understand the question completely, but our system's not reliant on measuring an earthquake. When we measure the right water levels, we'll go with the warning.
Well, I guess the question is, if there was a huge earthquake and, you know, like a magnitude 7 earthquake centered under northern Prince William Sound, you know, you don't have, you know, you don't have access to sensor information yet. You know, all you know is there's been a big earthquake. Would you, you know, what is your protocol at this point as far as
we don't have one for that.
Okay.
Right. Yeah, we would not, until we measure something or have some reason to create that protocol, we won't.
Okay.
That's something you guys could give some thought to, though.
Mm-hmm, mm-hmm. Kelly, did you want to try again? I don't know if I don't see a phone down here, but no, I still can't hear you. Okay, I'm really sorry that didn't work. So I wonder, Gabe, if you'd be willing to talk a little bit about kind of your perspective on where we are, where we're going, and the potential for a cryospheric hazard center and how that would fit into all this.
Yeah, hi everyone. I'm Gabriel Wolken. I'm with the State of Alaska's Division of Geological and Geophysical Surveys. I manage the Climate and Cryosphere Hazards Program. You know, the Berry Arm, I think, is a big wake-up call for the state of Alaska. And, you know, we're really not in a position to, as your question was sort of hinting toward, to work towards mitigation right now. We don't know enough about most of these landslides. In fact, we're still working on identifying many of the landslides that could be tsunami generating landslides in coastal Alaska. And so that's really where we are with this. And so I think it's really incumbent on us to work with USGS as closely as possible to combine efforts with as many different partners as possible to really address this issue. And I think we've taken some first steps on that with the large proposal that we submitted, many of the folks on the call here. And that's really the first step for us, is to get a better understanding of where the hazards are, and then really learning about those, and then trying ultimately to develop a better understanding of where they are, how they develop, and we can maybe try to gain a better perspective on where these are so that we can focus on maybe adaptation scenarios. We don't have anything in place right now, and it's not really our mandate to monitor any of these landslides. But what we are doing in conjunction with USGS right now is really putting a lot of effort into remote monitoring of the Berry Arm landslide and some on the ground efforts as well. And so we're learning a lot from that. And so that's the first step. And then in conjunction with NOAA and this multi-agency effort, I think we're going to have a really good approach that we can then extend to various areas. I think a lot of this is going to inform how we go forward with this. Again, this is more or less a wake-up call with the realization that we have very little understanding of these coastal hazards that are so potentially damaging to many of the communities along Alaska's coastline. So in a way, we're right at the beginning. We would love to be in a place where we can do the sorts of things that Lars was talking about earlier, but we're simply nowhere near that at this point. We're still identifying the hazards.
Thanks, Gabe. So it looks like Florian his connection isn't quite holding up. I was hoping to hear a little bit about his perspective on from monitoring landslides in Germany and the Swiss Alps and the Alps and such. But I think that maybe this is a good point to open it up more broadly. If anyone has particular comments or questions that they want to put out there, and really feel free to take this in different directions. And I'd love to hear thoughts that anyone has on what we've heard so far.
It's Peter Heusler. So to me, I guess what I'm hearing is somehow in Norway, there was a mandate for Lars Harald's group to monitor. So I'm actually curious if he might be able to speak to how that came about. And I'm hearing that there's basically not a mandate within the US to do that. And I'm hearing that NOAA is willing to issue a warning when there's a wave in the water, but there's really not this connection from the landslide prior to the wave generation, other than sort of general knowledge that the USGS and others can help provide to understand how the landslide's progressing. So I'm curious about the mandate.
Yes, I can try to answer. Normally, like a large governmental work is initiated when you have a large event. But in this case, it was when we investigated one of these large rock slides in the West Coast, where I show you the picture, the Åknes large rock slide. And we concluded with some kind of a probability for this failure based on historical data and geological data in the fjords, actually. And it was quite obvious that this was a large threat, with Finn Løvholt at the NGI and his group also evaluating the tsunami part and modeling that. So this was so large consequences for the inhabitants and a serious, quite a large number of municipalities, thousands of people. So the society had to cope with that. Because you couldn't move people out of the area. So the government then made this. There was a political pressure in that region, actually, both from the industry and the politicians for the government. So they established this this code in our law that get the possibility to develop the area just in the hazard zone with the requirements that the monitoring was in place. So this was like the simple answer on this. And then this concept has developed. So now monitoring is accepted as a type of risk mitigation. But it's not an easy task because you have all the uncertainties connected to this warning. Because each slope is like living their own lives. So you have to like understand each landslide actually, because you can't transfer everything from one site to another one. Although you learn a lot, of course. So it's not an easy task to decide that okay, you want to use monitoring as for risk mitigation. But in general, I think you are in this initiation stage. So do the site identification, what kind of sites is problematic, and then do like the proper evaluation of the hazard areas to get this on place on the map, and then some kind of classification, and then. But you have the problems with earthquakes, and so you can have. Although I think maybe even though you have earthquakes, it might take some time before the landslide is going out. But you can have events both for earthquakes and not earthquakes, because we have landslide moving that fast. You can have these sites without any earthquake warning. And for the sensor technology in the sea, you maybe have less time. You haven't enough time to do proper evacuation. So that's also a question. I don't know if you answer your question. But
So if I followed you,
I don't know if you, Finn, want to.
Am I understanding right, Lars, that sort of if we were just to kind of simplify that story, it started with the geologists identifying something, and then it was really the regional citizens that pressed policymakers to implement some sort of a system. Is that correct?
Yes, that's correct. It's one of the mayor in that municipality which Åknes is situated. So he was very clear because he has the responsibility for the safety for people. So he took the responsibility. But we have a very close cooperation, of course. So it's depending on communication here, which is important. Communicate on proper way actually. But political pressure, yes, that was from the region.
I really like that.
Starting with the geological knowledge, actually.
Yeah, this is Gabe. I was just going to say I really like that approach. It's definitely one rare example of being proactive about this situation, because I think what you were alluding to previously is that sometimes it takes an event for that to act as a catalyst to begin a program that really addresses these issues. And so I hope we're not in that situation. I hope we can follow the lead of the Norwegians in this case.
But just a comment, there was also quite a lot of noise connected to this in like 2003, 2004. Some people thought we exaggerated the hazard. The government was not a bit like they had the regional politician and the mayor had to really make a big pressure on the government and the ministry actually. So it took some years. Yeah.
I guess at the time that this was the municipality's responsibility, which have migrated to be national. And it really started with just one site, and it has expanded, you know, slowly over the last 10, 15, 20 years to more and more areas. I think really starting at one spot, understanding that, and then moving to other places with a really thorough understanding, because I think Åknes is really a state of the art in that perspective. It is very heavily instrumented, and the experience from that case is now very valuable for many other sites. I think that's, but it really takes a lot of time. I think it's yeah. When I came in, it just started probably. Is that true? Around year 2000?
Yes.
That could be, yeah.
Just looking at the comment thread here, Kelly brought up like the you know, the need for really you know, for information. So she says our main concern is that as average citizens and even city admin, how to get current updates. If we have an early warning system, we can move our assets and reroute ships and tours. And I think that I wonder, maybe I'm not sure, maybe Gabe would be the best person to speak to the process that sort of the agencies have been taking, or the government, the local government has been taking to get information out.
Well, I can speak about the Berry Arm issue in particular. We have and I invite Jonathan to jump in here as well. We have a multi-agency working group, and we're really tasked with addressing the technical and scientific issues on the Berry Arm unstable slope. And you know, a lot of that involves monitoring the slope with remote sensing assets to understand the motion and to try to characterize the landslide specifically. And so our plan of action with that has been to, you know, discuss the results and make sure that they're verified results with other resources. And then, you know, try to get that information out, if there is information that has changed, to try to get that out. And the best way that we tend to know how to do that is to have a multi-agency press release, and that's what we have done, that reaches the greatest number of stakeholders in one shot. And there's stakeholders throughout Prince William Sound, of course, that are interested in this. And so as scientists, we come up with the information, and then we have a communication team that is comprised of communication individuals from all the different agencies that get together to typically formulate the press release and put it out on social media as well. And then we update the website following the release. And that's been the protocol so far.
I know Milana's had experience in the Alps with landslide warnings. I don't know if you wanted to speak to that at all. Inject that into our conversation here.
Sure, I can try and maybe contrast it a little bit to sort of what we're seeing in Alaska and what Norway has. And to that end, my perspective on this is fully sort of from working for a consulting company that did a lot of natural hazard warning systems and alarm systems. And I think we don't have that, like Switzerland doesn't have sort of the national mandate situation that we're seeing, or from what I hear is sort of the case in Norway. It happens at a lot of different levels. And it often comes down to sort of what infrastructure is threatened. So if it's something that is, you know, if it's like a little municipal road, then maybe in this case, the municipality would have approached GeoPrevent, the company that I used to work for. If it was a national highway, then funding often came from the federal government and oftentimes also the canton, so which is sort of the state level. So oftentimes there needed to be communication and funding coming from all three different levels. And in our case, obviously what that warning or alarm system looked like was really dependent on the specific hazards. Tsunamis are not really our most desperate concern in Switzerland, and with the exception of a few lake locations, obviously, or reservoirs, like hydropower reservoirs in the Alps. And so it was always really a part of a really integral hazard management that sort of first had to assess, like, is a check dam the most useful thing in this case, or is an electronic warning or alarm system maybe more adequate if it's something that isn't going to happen all the time, but is sort of the low probability, high magnitude case, or you need to get people out in time, but you don't want to build a giant wall to keep the rocks from hitting something or so. So yeah, I don't know if that helps, but happy to answer other questions, of course.
Yeah, I think, Jonathan, when he was speaking at the beginning, like mentioned their, annual $4 million budget for, all of the US. And I'm curious, I'm curious, Milen, like how much is spent on that sort of a monitoring situation? And then Lars and Finn, like what does the money end of this look like in Norway? Maybe Milen first, since I just called on two people.
Yeah, sure. Yeah, that's an excellent question, Hagen. It's really hard for me to know, since also GeoPrevent wasn't the only person or the company doing this kind of work, and of course there are, like, if you go into the more structural measures, oftentimes you're just dealing with construction companies and stuff. So it was always like geologists identifying the problem. And so some of those liked to work with GeoPrevent as a company, and they would come to us. So the identification process sounds similar. The systems were on the order of, tens of thousands to maybe hundreds of thousands of dollars for sort of the 5-year period kind of a thing. But I have no idea what it amounts to, like, nationally.
And then those systems were systems. Did GeoPrevent, did they actually watch, do active monitoring with those? Was there someone else who was watching data streams? Like, what about that kind of 24/7 kind of perspective? Oh, I don't hear you now. Oh, there you go.
Sorry, I've seen it. Yep. That depended really on the problem at hand. In some cases, this was just information provided to experts that they would just, to a geologist or someone that they would just look at once a day, once a week, depending on sort of the situation. Or we had systems that were completely autonomous and would just trigger an alarm, whether that's a siren, whether that's a traffic light, whether, whatever. But we did all of the analysis, we did all of the data checking, and all of that was available on a data portal that was, so if it was a municipality, or let's say it was a power company and they have a geologist, so the geologist has access to this data portal where all of the data is continuously reported. So it wasn't like, it wasn't so much providing regular reports, it was just sort of a continuous data stream of these measurements available for interpretation to geologists or whoever was in charge.
And Lars or Finn, like what does the money end of this look like in Norway?
For example, for my section, which is responsible for the entire country, we have 18 persons employed, more or less on full time, most of it. And then we have like additional contract with companies and so on, also for some of the instrumentation and also follow up. So we have a budget of about like 2 million euro each year for the maintenance and operating everything. So that's what yearly, like on yearly basis. And then of course we have done a lot of investments in addition, of course. But but the advantage now is that we have like the satellite INSAR data, which can be used both for identification mapping and some kind of monitoring. But the problem, so technology is maybe there is something there which is quite available, but the problem is who is responsible, and that had to be real clear. Very clear and defined responsibilities. Otherwise, you are like you are in trouble.
One of the situations that,
so if you have a lot of data and nobody is taking the decision,
yeah, we have this glacial lake near where I live, Gruink Lake. Anya now has a funded project there, and hopefully there will be monitoring going in, with the scientific priorities. But it poses a significant hazard. It's a tourist destination. There can be hundreds of people there on a nice summer day, and so at this point, our approach. I've been speaking with like the emergency manager at the borough level, the sort of regional level in Alaska, and we have an open conversation there, and we're at some level going to try to do our best to do something, but there's no there's nothing concrete and systematic there. The responsibilities aren't clear. I think that there are a lot of weaknesses in where we are right now. And we're early in the process of it. We don't have monitoring in place, for instance, yet, but we're headed that way, and we kind of need to figure out some of those key questions.
Just to follow up, because the case is that you begin to get a lot of knowledge, and then nobody knows how to handle this, and that's you are in real trouble. Because this responsibility it's really important, and it's really had to be well defined, and you have to know. So we have to know what my section is doing, what the police is doing, and what the municipality is doing, and everything has to be clear cut in the plan, because you really needs this cooperation in the crisis. Who can you trust on? And the people out there need to trust this system. So this is the most problematic with knowledge. You get new knowledge, and then you don't know how to handle it.
First, as closing words for today, this is wonderful. What would be your advice to us and where we are? What would be a good driving motivation for us, or goal for us at this very time?
I think it's quite simple, Brent. What is the current knowledge? What do you know? So you really need to keep to basic knowledge about the situation, and then you have to communicate this, because you are members in governmental bodies, so you are obliged to inform people about your knowledge. So this is the basic thing. So you have to communicate it. You have to inform people and your government and your leaders and so on. So this is important, because if it's next year is coming a large event and a lot of people is killed, and then they ask, was there somebody who know this? Why haven't you informed good enough about this situation? So this is really an important issue for you, I think. open about your existing knowledge, but also point to the uncertainties connected to this. This is what we know now, but there is uncertainty, and you have to communicate that also.
Well,
Thank you.
Right
That
on.
was-
Yeah. No, and we're coming up right on the hour, and that's I think very good place to close. But does anyone have any last comments here?
I really liked what Lars Harald had to say. I think often the struggle is that sort of communicating what you know, but without sort of crying wolf too often. In that we know there's this hazard there. You don't want to overplay it. You don't want to underplay it. And then somehow finding that balance of, what's it mean in our lives is a struggle.
Just to comment one thing more, because as scientists, researchers, and experts, we can do a lot, but we had to relate to the society with politicians, with the bureaucracy. So we had to work together to solve this. So we can't be alone. So we had to find this kind of communication and relations with other parts of the society to solve this problem.
Lars, I have one last quick question. How much of the actual measurements that you're making are visible to just anyone in the public? Is that filtered sort of and released as little tidbits of data, or is it kind of continuously visible?
It's not continuous visible, but we make reports, like weekly reports about all our monitored sites with some kind of general movements and so on. But I think we will be coming into an issue where most of it should be open. So I think we are moving towards that. But that's also, it's a large case connected to this also.
Right.
It's not easy. Yeah.
Thank you. I think that's a really interesting thing to think about. Food for thought.
Well, thank you, everyone. I think that was a really great discussion. I'm gonna, I'll set up another meeting. I haven't figured out a topic. I'm absolutely happy to hear suggestions. It was unfortunate that Kelly wasn't able to speak more because of her audio issues, but I think that there could be a lot of value to having members of the public here. So, and I think that maybe my internet is crapping out on me. So thank you, everyone, very much, and we'll be in touch.
Thank you a lot.
Thanks. Bye.
Bye.
Thank you. That was great. Bye.
Bye.
Thank you. Appreciate it.